Thanks for joining us today on the second day of our HPC on AWS conference. I'm Barry Bolding, Director of HPC at AWS. And to kick off today's schedule of events, we have a couple of special guests. We have Earl Joseph, the CEO of Hyperion Research and the Executive Director of the HPC User Forum. Why don't you wave at everybody there, Earl? And we have Alex Norton as well, one of the chief analysts at Hyperion, who covers HPC in the cloud. Great. Today, we're actually going to have a fairly informal discussion around the marketplace and some key questions. I will be asking some questions of the Hyperion folks, and they'll dive into it, and we'll just have a conversation. Today, I just want to give you a little bit of background. You know, Hyperion, if you're not aware of it, is one of the most experienced and trusted analyst companies covering HPC today. I don't want to go into how many decades of experience Hyperion has on the team, but they've been around for a long time, and they really understand some of the important issues that affect HPC today. Welcome, Alex and Earl. Why don't we kick this off? First, I really have a 10,000-foot question, which is, you know, can you give us an overview of how HPC is growing today, and if and how cloud may be changing the way people view high-performance computing?
Sure, thank you, Barry. So right now we're seeing HPC a little bit in a slump because of COVID this year. But if I ignore this year and look at last full year of 2019 was actually a high point for high performance computing. So it actually exceeded $13 billion in on-prem server sales. And on the cloud portion of it, we had to restate our cloud forecast for last year because it came in $1 billion higher than what we were forecasting earlier in 2019. So we're seeing a lot of new technologies enter the market, and it's just to me, it's a fascinating time to be in the market because there's new hardware, new software, new interconnects, new players, and everything else. And the interesting thing for us is that if I look back 5 to 8 years ago, there were so many HPC jobs that just didn't do well in the cloud. You know, when you put them up in the cloud, they ran quite slowly. And in the last 18 months, the world's basically changed from our perspective. The number of HPC jobs that run on the cloud and run well on the cloud has just increased so dramatically. So for last year, we felt that there was roughly $4 billion of HPC dollars spent in the cloud to run HPC workloads. So just fascinating shifts here. The other major shift we're seeing is this whole focus on the growth of the systems. And again, if I look back 10 years ago, $100 million would buy you the largest supercomputer out there. If you look back 3 or 4 years ago, yeah, you had to get about 250 million to have a largest machine. And this year we saw the first $1 billion system sold, and that's the Recon machine. And if you look at the exascale machines, they're all coming in at between $500 to $600 million. So if you think of Moore's Law's curve as far as how much things are speeding up, the budgets are speeding up at faster than Moore's Law's pace right now, which means the world is going to redefine itself. And the Department of Energy started by saying there's 3 new pillars of science, you know, traditional modeling, simulation, AI, big data analytics. Well, for a lot of sites, you're not going to be able to afford to buy all that stuff. You're not going to be able to afford to have custom, you know, AI processors and everything else. And that's why I think the cloud is going to really kind of hit the next tipping point, is where people start to try new algorithms, new software, try new hardware and everything else. Hey, let's try it first on the cloud. And the other thing that we're seeing is, of course, the whole big data phenomena. And that's been rolling for quite a while. It got accelerated with machine learning and deep learning. And so where is the bulk of the data right now? A lot of the data is in the cloud somewhere. And if you're going to do processing, machine learning, deep learning, it makes a lot of sense not to move that data around too much and to actually do the processing in the cloud. So those are a couple of mega trends that we're seeing right now. Barry, I think you're on mute.
I am on mute. Sorry about that. You mentioned a couple of trends, and maybe we could just have you expand on them a little bit. You mentioned that you know, that there was this expansion in the cloud, and then you mentioned the large-scale procurements. Those large-scale procurements typically are done a few years before. And so my guess, my question has that been affected by COVID and some of the changing market dynamics? And, what is COVID affecting? Is it affecting the large deals? Is it affecting, the enterprise? Is it affecting, the universities and the public sector? Where is this strange time that we're living in, this COVID time, having the biggest effects?
Well, let me start with how it's impacting us. Is we have to do a major update of all our forecasts every quarter because the dynamic changes are just happening so much. Earlier this year, when we did a lot of our surveys of buyers and vendors, what we found is that the supply chain itself, meaning once the processors are made, not too much of a delay. The moment they leave the foundry, shipment delays, delays in all kinds of components, printed circuit boards, and then inside the factories, hey, sometimes these factories wouldn't let people in the door for weeks on end because of the government rules or concerns. So we saw this whole supply chain slowdown taking place. Then on the buyer or user side, there were a lot of issues as far as allowing people in the door to install the system. If you're not allowing your employees in the door, you may not allow somebody to install systems. But we found that at the very high end of the market or larger, data centers, they solved that problem fairly quickly. So the really large data centers tended not to see as much of an impact, but then the rest of the market quite dramatically. Now, the areas we see the massive impact, oil gas, is hitting COVID at the same time oil gas prices are at all-time lows and people are not flying, driving as much and everything else. The oil gas sector is really feeling the pain of this most heavily. Next, we see the manufacturing sector is seeing some significant impacts. People aren't buying as many airplanes and other things. And then the other big area as far as the vertical is the movie studios. Movie production has all but stopped, so some significant impacts there. But you had mentioned too the exascale portion of the market. We have not seen hardly any impacts to the exascale outside of what I'd call normal technology delays or issues. For example, Argon will no longer be the first US exascale system, but it's not because of COVID. It's because of some technology issues. After all, most of the exascale machines are true R&D machines too, meaning they're developing the technology at the same time they're going to be installed. They'll be the first test bed for many things. The other part of the market, though, that is under severe pressure is the very low end of the market. We call it work group, and these are on-prem servers that sell less than $100,000. Now, they were under pressure before COVID hit. And what we saw is they were the first ones that started moving a bigger portion of their workloads to the cloud. Now, what's happened now with COVID? Many places you have to shut the door and don't allow anybody in the door. So the old value proposition of cloud computing is, hey, let's use the cloud just for your peak workloads, taking care of peak workloads. Well, nobody back then really thought of the peak being 0 and then 100%. And if you think of a small business that has to close its door for a month or two, then the government says you can open your doors. So tomorrow morning you want to turn it all on, and maybe a month from now you're going to have to close your doors again. That cloud value proposition of being able to turn that expense on and off completely is dramatically powerful there. So we're kind of expecting the work group to see the kind of the biggest shift first in all this. And of course, it's always by the type workload. The embarrassingly parallel problems went first. Now the other ones that fit well in the cloud, and then there'll be some set that'll stay on-prem for a longer period of time. And Alex, I don't know if you want to add anything to that portion.
No, Earl, I think you covered all the key points there.
Okay.
On that.
Can I ask about a couple of segments that you didn't mention in detail? Given COVID, you didn't say a whole lot about healthcare, life sciences, or financial services, both of which have been also impacted by that. Is there any change in those segments as well?
Right. So one thing I did forget is the positive news about COVID. So the healthcare, life sciences, and that, and underneath that too, also the government labs that are doing healthcare things. Those are seeing actually growth. We work, worldwide with a lot of governments in that. We expect to see new data centers actually constructed and new systems sold just for combating COVID and COVID-like situations and the economic outcomes of that. So that is what we say relative to everything else in the world, a higher growth area. The bio life sciences, healthcare, and government labs that kind of support those whole areas. The other big growth area is the public cloud computing, because we're seeing a lot of people delaying purchases. If you're any kind of organization with the budget and economic pressures right now, it's kind of nice to move it to an expense versus capital purchases in this window. So we're expecting to see quite an uptick in public cloud computing. The same thing that we're always trying to measure in our surveys is once somebody tries something new, do they only do it part-time and go back to the old ways, or do they stay with the new way? And in general, people, once they try something new, if it's successful, they stay there. You know what I mean? It's usually not just a temporary solution. So those are some of the kind of positive news that we're seeing in the market also. The finance sector, we kind of put that in the neutral ground. We don't see that having an acceleration or a deceleration at this time. It's always been under a strong growth area. So I'm kind of saying that it's going to continue on a decent growth path.
All right. As I think about some of the challenges that HPC in the cloud has faced historically, we used to hear a lot of concerns with things like security and blockers around those types of concerns from customers. But to be honest, I don't hear as much of that when I go out and I'm talking to customers. It seems like it's assumed that cloud is secure. Are you hearing that, or are you hearing other types of things that people worry about as they're thinking about moving to cloud that aren't on the conventional list from a few years ago?
And Alex, I think you might have some survey results in that area.
So in pretty much every study that we run about the cloud, we continually ask users about their inhibitors, what keeps them back from either adopting cloud from zero or increasing their cloud usage. Barry, as you mentioned, we don't hear a lot about data security, but in many of our surveys that still ranks very high. Users are very aware of where their data sits. So data security does still remain a very high barrier for users, despite the number of ways in which cloud providers have addressed security concerns through certifications like FedRAMP, addressing GDPR concerns, becoming HIPAA compliant and certified. So data security still remains quite important as users look at the cloud. But beyond data security, and possibly becoming a much bigger issue, is data locality. The ability to move your data around, especially with the growth of AI for HPC, data sets are very large, and it can be very expensive and timely to move those data sets from an on-premise data center into a cloud platform or vice versa. So data locality, data movement, those remain very, very high barriers. And then third, cost still remains a very high barrier for some users. We are seeing for some workloads that the cost effectiveness of running in the cloud has become appealing compared with on-premise computing. So there are certain workloads that are actually more cost effective to run in a cloud environment than on-premise. But for other workloads, it can be extremely expensive to run those workloads in the cloud. So for many customers, cost is a major issue. And part of that remains with the data movement. For large data sets, it can be very expensive to move those around either within a cloud or from an on-premise data center to the cloud. And then the fourth that I wanted to mention that we've seen really strong movement to address by the cloud providers is the ability for cloud providers to speak in HPC terms and to have HPC expertise. Hiring HPC experts to work for cloud providers and be able to speak directly with HPC customers, understand the needs of their workloads, and to truly kind of help in that migration has been helping and really allowing more HPC users to take advantage of what the cloud can offer. The education in terms of what a user needs to do to run in a cloud, that process and aiding in educating users on how to take advantage of the cloud has been really great in helping the adoption for HPC users. So it was a barrier and now is becoming less of an issue. Or would you like to add anything to that?
Well, I agree completely. And a number of sites are actually seeing that the cloud providers like AWS actually have higher security than they have on site. And they're finding that to be a tremendous advantage. In general, it even starts at some basic things. The AWS institutes or installs the upgrades very quickly. Whereas if you look at most on-prem organizations, to get one upgrade, as far as security upgrade done, may take more than multiple months, as opposed to doing multiple ones a day. And so they recognize very quickly that there's some fundamentals there that are really good.
Well, those are great insights. In fact, it's good to hear about especially the experiences. Last year, I remember back when we actually did conferences in person at Supercomputing last year. The AWS team led a HPC in the cloud tutorial with over 100 attendees, and one of the most successful tutorials at the conference last year. Now, this year, we're going to be trying to do that virtually and do a tutorial. But it's good to hear that those types of education are having effect on having people understand that there's a lot of expertise in moving applications into the cloud. Maybe we could shift gears a little bit. Yesterday in our virtual event, John Preskill, Amazon Scholar for quantum computing, gave the keynote, and so I want to kind of shift gears to quantum computing a little bit. AWS announced our bracket service in August. What trends are you seeing with new HPC technologies such as quantum computing or ARM or other types of technologies that are evolving over, say, a 3 to 5 year time frame rather than just a 1 or 2 year time frame?
So quantum is a very fascinating area for us. Thanks to the Department of Energy, we're actually doing a multi-year worldwide study to try to find every quantum research program on Earth, if you can imagine that. And one of the issues we hit 700 very quickly. And so then the program turned in to find everyone which is meaningful. So we actually had to, in the middle, stop a set of surveys and come up with definitions for what is meaningful, because there's just so much work going on right now. The other part is the cloud model for quantum computing today, and for the next X years, I'm going to say, because with quantum, you don't know what X is, meaning when it gets to certain points, makes tremendous sense, because the hardware itself, in most cases, is very costly. To maintain the temperatures, to manage the hardware is costly both for the hardware itself and the installation portion. So having access to cloud like you're offering now with D-Wave, Rigetti, IonQ, and all the programming part, because the biggest issue for most users right now is, what do I use it for? And once you answer that question, how do I use it? How do I program it? How do I get access? So we think that in the short term, again, could be multiple years here, I'm not talking months, is training people how to use quantum, where it fits, perhaps even frequently a hybrid model where you do some optimization on the quantum computer that then drives your regular traditional HPC work, and to get to an optimization much more quickly. So for other people that we're doing studies for, we actually were asked to measure how much people are spending on quantum computing today and likely in the future. And we actually were a bit surprised. We think right now for 2020, there will be $320 million spent on quantum computing. So 320 million is way larger than we were originally expecting until we did all the research. And a big portion of that is being spent in the cloud as opposed to on-site. Because we originally thought at this point in time, if you added up just the D-Wave systems, you get to a pretty good size number, but it's not this size number. We also, from that study, expect the use of quantum computing to grow around 27% a year. So tremendous growth there. Let me put that growth in perspective. For HPC, which we think is strong growth, is somewhere between 7 to 8% CAGR over the next 5 years. So quantum computing at 27 is very high. And as you mentioned, new technologies. The other area that's in that area like that is AI, machine learning, deep learning. We expect that to grow at a very similar rate of around 30% a year. So just some tremendous things there. Also with quantum computing, because quantum, and so does AI, but quantum more directly, has this ability to do things maybe 1,000 times faster, maybe 1 billion times faster. And frankly, Barry, you and I remember the great days to do things you can't do on other systems. The real big one. So there's national priorities right now. And so many countries are investing very heavily. First of all, they don't want to be left behind. If somebody makes a massive breakthrough on quantum and is able to do something unbelievable, unless you're, training your own folks, up to speed and everything, you could be left behind competitively on all dimensions. So we're very bullish on quantum right now. We don't know how soon it'll happen, but at the same time, we have seen many success cases already.
That's really cool, and I'm that you guys are beginning to see a market, and size that market for quantum computing. Any other technologies besides quantum that we should keep our eye out for the 3 to 5 year time frame, or any you want to mention today?
How about if I start and then Alex, is the number of new processors are unbelievable. I mean, Intel still is the market leader and we expect x86 to continue there. NVIDIA has done a tremendous job on the accelerator GPU side. But if we look across the horizon, you see ARM showing up now, Fujitsu with their very high-end ARM, but then, the lower-end ARMs. But Alex has been tracking all the new AI hardware, and it's just amazing what can happen when you do these targeted processors. And Alex, maybe you can speak to that a little bit.
Yeah, thanks, Earl. There's as Earl said, a large number of startup companies and large companies who are investing in, let's call it novel architectures to address AI workloads. Something that we've been paying attention to is beyond the NVIDIA GPUs and some of the FPGA options out there, there are a number of emerging technologies in analog computing, vector computing, photonics. We saw the large announcement of the wafer scale chip, the large one, the biggest computer chip ever created. A number of companies coming up with their own 3-letter acronym to describe their processor, and also a number of companies that are differentiating between training-based processor architectures and inference-based architectures. So splitting out the data center AI chip from the edge AI chip. AWS, for example, has their Inferentia chip, which is designed for AI workloads. So there's a number of other companies that are on the horizon who are trying to address how do we run AI workloads at larger scales, faster time to better results. So that's an area to definitely focus on as well.
All right. And Barry, maybe I could add one other area that's a little different than the technology, but you asked about, new type things. And this is related to the budget growth I was referring to. The desire to do more HPC, more science and more engineering, people have been able to convince their governments to spend, $600 million a computer, $1 billion in the case of Recon. What we're seeing in cloud computing, because if you're solving the budget issue, then the cloud, you could spend a ton of money and have access to unbelievably sized system. So what we're thinking is, as people grow their justifications for doing more HPC, to be more innovative, to make more discoveries, we think that there's a potential for just some tremendous growth on the cloud computing side. Now, our current forecast, as I mentioned, in last year, 2019, the spending in the cloud was just under $4 billion a year. We're expecting, without any new tipping points, that by 2024, that to be $8.8 billion. So more than doubling. But every time we present our forecast, we tell everyone, we just missed this tipping point last year. We expect there to be at least 1 or 2 additional tipping points that would take it much above that number. But we think the cloud computing, like AWS offerings, they're becoming much more scientific and HPC friendly, much more capable at doing scientific workloads. And the desire to do a lot more science, we do these surveys where we call it pent-up demand. We ask sites, if you didn't have a limitation on your hardware and the size of your hardware, how much workload do you really have that you'd like to run? And the numbers are just amazing. They instantly can find a way to run 50% more. And then within a little thought process, it's much larger than that. So what you have in the world is this desire to do a lot more science, and you're limited by what you have on-prem. And so as long as you can make the budget argument, because I would suggest that once you make the budget argument, you could just go spend it in the cloud right away, right? On that part. So that we're watching this budget argument, and we're actually watching at the EU level, Japan, China, the US, to see how that evolves, because it's already more than doubled the size of on-prem systems. And we expect there could be another doubling soon. And I'm not sure that you can put all that money on-prem, you're going to spend it somewhere.
Right, right. No, well, I mean, these are exciting innovations, and it does show us that we have a lot of work to do over the next few years. Is there anything else in the AI ML? Because I know that Exascale and some of these have initiatives to incorporate complex workflows involving AI ML and HPC and coupling those workflows together. So it's not just about technology and chips; it's about some of the workflows and software. Any other insights with regard to how AI and ML and classical HPC workloads are going to tie together or work together? Are you seeing that in any particular segments, or is a lot of that confined to the exascale future development domain?
So we're seeing AI injected into pretty much every space of HPC right now. Beyond just independent AI workloads, we're seeing AI being applied to traditional HPC workloads in manners such as data pre-processing, data post-processing. We're also seeing traditional HPC simulations generating data to feed into AI training models. And we're seeing the two meshing into a single workflow where AI and traditional HPC are actually helping each other. And so we're seeing that impacting things like heterogeneous system design, or looking at how can workloads take advantage of accelerators. If you have a machine that has accelerators in it, then you want as many workloads as possible to try and take advantage of those. So we're seeing not only AI workloads taking advantage of accelerators, but some traditional HPC workloads taking advantage of accelerators as well, both for the AI portion that's being integrated, as well as some of the traditional processing as well. And then the other thing we're seeing, and Earl touched on this earlier, is data. In the AI space, data is becoming the most valuable asset, not just the quantity of data, but the quality of that data, the diversity of that data, the type of data. And the cloud provides a really interesting and valuable location to both store that data and collect from other sources. So whether it's edge devices collecting data in a cloud environment, or sourcing public data sets that are already stored in the cloud, AI in the cloud, we think will grow partially due to the fact that the amount of data that already exists on the cloud and is accessible through the cloud. Earl, would you like to add anything to that?
No, the only thing I would add is, to me, it represents a lot of exciting changes that can happen in the industry. When you take AI, HPC, massive data sets, I think we're going to see a lot of interesting solutions to problems, but new opportunities that are generated from that across the board, whether it's for healthcare, just making our lives better, down to car insurance reductions and everything else with autonomous vehicles. And the precision medicine is one of the biggest use cases we think that's there on the horizon. And that's probably where it could help everyone's health dramatically. And even with the COVID situation, once the vaccines are figured out, once it's applied in that, and then if it's applied at a genomic level, the outcomes could be tremendous as far as solving these types of viruses in the future.
Very cool, very cool. So I think we've reached the set of questions that I had in my mind as we sat down today. But maybe I could just offer up a minute or two for any closing ideas or statements that you guys have. Any last words you want to offer up to the conference?
I can just mention that I think we're in a really exciting time in high performance computing, where there's all these new products that we talked about, all the new technologies that are on the horizon, and then the major shifts that we see changing. I mean, who would have thought that we'd be talking about 3 different pillars of HPC versus traditional modeling and simulation. I also think that it is the path to get out of the COVID virus situation dramatically faster. And if you look behind all the drugs that are being developed, all the treatments and that, there's HPC just finding discoveries all over the place. So it's very exciting that it's actually helping us today in the middle of this situation that we have right now. And Alex, you may have a few things to add.
I think that's I think everything that I wanted to say was covered. I do agree with you, Earl. I think it's a very, very exciting time for HPC. I think looking at the next 5 years of what an HPC deployment might look like, and the ways in which resources are going to be considered both on-prem and in a cloud environment, and what does the meshing of those two worlds look like for solving the plethora of diverse HPC workloads that are now including AI and including some of the traditional HPC applications, I think is really exciting. I think it'll be a fun couple of years.
Well, I hope that next time we gather, we'll be able to, sit down and talk in person. Let's keep our fingers crossed and that these vaccines will be out quickly, and that HPC will help to accelerate that. It's been a great conversation today. We have a whole host of speakers coming up over the next few hours. And we really thank you guys for joining us at our first and hopefully last HPC on the Cloud AWS conference. Like I said, maybe the next one can be a conference in person that we do rather than a webinar conference. But we'll do the best we can, like everybody, and stay healthy and good luck. Take care.
Great. Thank you very much, Barry. Appreciate it.
Thanks, Barry.
Yeah.